Hello, my name is Grigory Trofimov, and today I will talk about how service virtualization can simplify software development and how to take it even a step further to unlock some significant ROI across the board. Please enter your questions for me in the questions box. I will go through them at the end of the presentation. The webinar replay will be provided to attendees soon after the event. So today's topics, we'll start by taking a step back and looking at why service virtualization is so popular across dev, test, and ops. We will then look at taking the next step and making our virtual services a little bit smarter and seeing how that can help us get additional value from service virtualization in our software development practice. And we'll, of course, look at how we can scale these solutions across the enterprise, make sure we are reaping maximum benefit. So with that being said, let's talk about modern application architecture. So modern applications are you know, today they're really consisting of services, APIs, in today's modern API economy. And APIs and services are a lot like a faucet, where you can turn on a faucet on and off, and if you see water coming out of the faucet, you would assume that the faucet is doing what it's supposed to do. It's pushing water out. Check the temperature. The temperature is correct, and you don't really think about much that requires for that faucet to come, that water to come out of the faucet. But if you think about it, there's a water heater that heats the water. There's a pressure regulator that regulates the pressure. There are pipes that have to carry the water to the faucet. So there's a complex system behind the faucet that actually allows that faucet to do what it's supposed to do. And modern applications are similar in that way, where your APIs don't necessarily do much other than return a response, but then it takes a complex orchestration of interdependent systems in order to deliver that response. So if we're looking to validate a specific endpoint, or a faucet in this case, we can leverage service virtualization in order to simulate some of the components within our system, in order to simulate specific conditions or to validate various components within our house. We can also leverage it to isolate specific components, for example, the water heater, or maybe making sure that filling up a bathtub will actually produce consistently hot water. And so service virtualization can help us with that. But the main challenge, of course, is the fact that in order to test a faucet, you need to have a house. In order to test APIs, you need to stand up the complete system, the complete architecture. And this, of course, leads to some common challenges. And the challenges really kind of come down to environment stability, right? So environment stability challenges are across the board in development, right? In development, we see service virtualization being able to help developers stand up sandboxes, make sure they're not pushing untested code into production. Prototyping, collaboration, TDD, all of those things can be enabled with service virtualization. On the testing side and the quality assurance side, of course, environment stability, environment availability is a fundamental requirement to do continuous testing in order to shift left. And then on the operations side, we see service virtualization being leveraged a lot for sales environments, training environments, customer integrations, right? Bringing customers on board if they are leveraging your APIs in order to integrate with. Want to make sure they have a good dev portal that they can develop and test against. In order to achieve good customer success, you want to be able to provide that for your customers. And service virtualization can help reduce the costs and the resources required with standing up these types of environments. But what are some of those common challenges? What makes test environments so brittle, dev environments so brittle? Why can't we just stand up environments real environments whenever we want. We consider these the ABCDs of service virtualization, and it really comes down to four things: accessibility, basically not having access to endpoint because of its availability, or maybe its development schedule, maybe it's being developed on a different cadence. Behavior, so being able to simulate specific conditions, being able to test specific flows, end-to-end scenarios does require certain behavior states, and achieving those behavior states can be difficult in a complex architecture. Cost, so third-party dependencies, of course, will have scaled costs associated with them. So if you want to do performance testing or something like that, but have to pay for every single hit to the system, the costs can scale out exponentially. And of course, data. So working in a shared environment means sharing test data, or sharing the data that is in that system. And when you're sharing data, you're always running the risk of someone else consuming that data, or burning essentially data, and not really allowing a lot of reuse from that perspective. So being able to isolate environments from a data perspective really comes into play here. And these challenges really manifest themselves in test automation. So in your test automation adoption, you're going to find the right tools. You're going to find the right people. You're going to have a nice, friendly ecosystem that has all the tools necessary for you to actually test your application and shift left and enable continuous testing. But all the challenges that we mentioned with regards to environment stability will still present a significant roadblock. Continuous testing demands having access to a continuous test environment. So not having that access can lead to agile roadblocks. And service virtualization can really help here, right? So addressing some common challenges like unavailable or fee-based third-party systems, uncontrollable behavior, not having the ability to do shift left performance testing. Service virtualization really checks those boxes, right? It allows you to simulate the behavior of real systems. It allows you to simulate data that can be reused not only in service virtualization, but also in your testing practice, and really, seems to nip this whole environment availability challenge at the bud. But the adoption journey can be interesting, right? So very exciting. When you start with service virtualization, often we start with the lowest hanging fruit, right? Essentially, use cases that are so glaring that they basically have immediate a return on investment. But in service virtualization, we do kind of see this 80-20 rule, where you have some use cases that are very, very basic in their requirement, right? Maybe it's just a 200 ping that we need, and we don't necessarily need a complete service virtualization solution in order to achieve that. There are mocking and stubbing and open source solutions that can do very basic things very quickly. On the other hand, we have really complex flows that require a complete system or a complete backend system in order to execute those flows. And those use cases, as they grow in complexity, the level of effort associated with virtualizing those use cases goes up as well. And so in those instances, sometimes you see organizations say, well, perhaps in this case, we just might as well, stand up a real service or stand up a real backend system. And that kind of leaves us with all these primary use cases here in the middle, which are your common, REST, JSON, MQ, JMS sort of type of services that are really good at looking at the request and identifying the correct response, looking at the data, incoming data, and picking the right data set in order to return that response. Service virtualization really shines in these use cases. So having the right solution and having the right strategy really enables a return on investment there in these types of use cases. But what we are going to see is that in that last 10% where the complex use cases get a little too difficult, there's significant ROI there. And so having the right strategy, having the right tools, and having the right approach to virtualizing some of those more complex behaviors can really unlock significant ROI, can make a huge difference. So what are some of the common challenges? Why, why are sometimes we constrained from a service virtualization perspective to these, to these 80%? Well, a lot of times it just comes down to protocols and message formats. There are a ton of different message formats and protocols out there. And, you may have some obscure TCP custom message format that is being called by a payment processing service that not a lot of service virtualization solutions support. And so in that sense, it's important to pick the right service virtualization solution, right? You want to make sure your solution doesn't just, do REST or JSON or SOAP, but can also do some of the other things, more complex things like Kafka, Rabbit, EDI message formats, Fix, Swift, TCP, SFTP, so on and so forth. Not having access to the protocols or a vendor who is willing to support them might leave significant value essentially on the table if you're not able to virtualize those types of services. So inventory your services and make sure that the solution that you're using can cover those use cases. Moving to more complex scenarios, there are two primary types of scenarios that we're going to look at. So sequential state changes, simulating a sequence-based flow. A lot of times, event-driven architectures will have a type of flow that requires a service to change state based on some external event, right? So your application, as you're interacting with your application, you may request to get some information from your service. That service then reaches out to another endpoint or another service and requests, well, what's the status? What's the status of this particular transaction, for example? The service will return a static response saying, hey, well, that transaction is currently pending. The next request comes in to again ask, well, what's the status? And the response is again pending. And for service virtualization, this is difficult because the request itself doesn't change, right? So you're not really looking at anything from a request perspective in terms of figuring out how that response is supposed to change. But sooner or later, at some point, when we finally request what's the status of this transaction, that service is going to respond and say, hey, this transaction is processed. So that state change needs to occur in a sequential type of way that doesn't necessarily depend on the type of request that's coming in. This is common with, services that are putting messages on a queue or polling a specific service, basically event-driven architectures that require these types of state changes. So from that perspective, there's something called sequence responders. And sequence responders allow you to basically create an order of operations based on the number of requests that are coming in. So a sequence message responder enables you to configure a sequence of literal response messages that are sent in response, that are sent in a series of responses for repeated requests. This allows you to achieve simple state changes across event-driven architectures. But then this can actually scale out into a much more complex use case. So rather than just having one service that you're polling for a get status event update, you may actually have an application that you're testing that integrates with many different types of services. For example, your service may be reaching out to one service to request some user data, and that user data will return some sort of user ID, which is then reused in a subsequent call to another service to maybe get some account data. This is a common end-to-end flow in banking, right? Your account data then returns an account ID. This account ID can then be reused to make a call to maybe some sort of payment processor. This payment processor will communicate with the account service and perform some sort of transaction, maybe a deposit or maybe a withdrawal of some amount from that particular account. And only then does does the payment processor return a successful status for our application under test? And this type of flow is difficult for many reasons. Number one, you have multiple services that are all in sync across their data, right? These user IDs, these account IDs, these transaction IDs, they all need to be in sync. They all need to be synchronized across all of these services. So when we talk about virtualizing this type of flow, we're talking about virtualizing more than one service and more than one type of data set that has to be synchronized across those services. Not only that, there's obvious state changes that occur for all of these services. So the user information gets updated, when an account is updated, and the account is updated when a transaction goes through. The transaction record, transaction history gets updated when that type of transaction is completed. So there's all of these dynamic state changes that are occurring during the execution of this type of scenario. And we call this chasing a record, right? These types of scenarios, these types of end-to-end testing can be very difficult to do manually if you don't have the right data or you don't have all of your services up and running as required by that test. And even more difficult in test automation, where the demand for having these types of environments available is continuous, right? When you run your nightly tests, if either the payment processor is down or the account data doesn't have the right data set, those services, those tests, they will fail, and there goes the whole nightly run. So in that sense, it's important to have access to what are called CRUD tools: create, read, update, delete tools that can do these operations across multiple complex hierarchical data sets, right? Not just simple flat, here's your user ID, here's your user information. There's a lot of nested data sets inside those values, a list of accounts, for example, or a list of users associated with a specific account. Those types of data sets are highly complex, and your solution should be able to read, update, and delete those values. And Parasoft's CRUD tools in service virtualization can do just that and help you synchronize that data across all of those services. So how do we typically get there, right? How do we start creating these types of complex services? Well, the typical journey for creating a virtual service typically starts with the application under test and its dependencies. And one of the most common ways to develop a virtual service, not the only way, but one of the most common ways, is to essentially capture the behavior or capture traffic. We do that by defining monitors or proxies on the path between the application under test and its dependencies. We can record traffic. We can consume that traffic to create virtual services. So we can leverage that traffic. And what this does is it gives us a lot upfront. It gives us all of that data upfront that we can then reuse in our virtual services. And by using that traffic to create virtual services, we can then deploy those virtual services to the virtualized server. And this allows us to now reuse our application under test and hit those endpoints. But before we get there, let's actually take a look at that traffic, right? Because when we start looking at complex end-to-end scenarios, the traffic will contain a lot of the logic that is embedded in our application under test. And that traffic basically serves as a blueprint for how we should be developing our complex virtual services that will help us unlock that additional level of ROI. So when we first capture our traffic, right, we get a traffic file. There's a traffic file with some calls, API calls, or HTTP calls, maybe some other type of message format, but we don't really know upfront what's in that traffic. We have to leverage some tools, maybe AI, in order to decipher the flow inside of that traffic. And the first thing that we're going to do is we're going to want to identify the state changes across our end-to-end scenario. So starting with the first call where we do get accounts and then we do some sort of transaction, how does the state of our application changes? Well, all of that is inside of the traffic, right? In the traffic, we can see which services are being called in order to force those state changes. So identifying those state changes, inferring those state changes directly from the traffic can give us a lot of insight into how our application actually behaves. Next, we can infer the logic, because by looking at the traffic, we can not only see the actual API calls that are being made, but we can also see the contents of those API calls. And you're going to have user IDs, transaction IDs, account IDs, all inside that traffic. And based on that traffic, we can actually identify what the logic and what the flow is from those values, right? So identifying those account IDs, where they're being reused downstream by which calls, which services, will give us insight into how our application actually works. Now, this can all be very difficult to do if all you have is a traffic file. So what you need is a solution or a tool that can parse the traffic, and it can give you all of this information up front. Where are those state changes occurring? Where are those account IDs and transaction IDs? In which calls are they being returned, in order for us to simulate this type of flow in the most realistic and appropriate way? Parasoft Smart API Generator can help you do that, just that, right? So you can consume the traffic file, and it can break it up into API calls or essentially message clients that will tell you where those state changes occur, right? So, for example, you have multiple services, different types of services. Some are performing delete operations. Those are state changes. There are JSON asserters that can determine when the response changes and based on what conditions. And this will tell us that, hey, this particular API call actually returns a value that is different from a previous API call. That's an example of a state change. Additionally, Smart API Test Generator will create JSON databanks that stores key values like account IDs, transaction IDs that are being reused downstream in your tests or in those API calls. So having a set of API calls not only gives you a blueprint of how your application communicates with its external dependencies, but it also gives you a set of tests that can be reused when you're creating your virtual service, right? So by creating the virtual service and having the set of tests, you can validate that your virtual service is able to support these complex end-to-end flows because we already have the test that will validate that for us. Next thing, you want to make sure you have all the tools that are available at your disposal, right? We have the traffic that allows us to get some data up front, and that's really where this approach to service virtualization shines. Being able to capture traffic gives you a lot of data up front. But as we've mentioned, there's other ways to create virtual services. Another common way to create a virtual service is by consuming a Swagger definition file. So Swagger definition files or WSDLs or XML schemas, they can give us all of that structure for a virtual service, right? So the schemas, the resources defined by the virtual service, the structure of that virtual service are all defined within the definition file. But a lot of times we have to choose, right, between strategies. Do we start by simply creating a templatized virtual service that has all the schemas and the structures, or do we leverage the traffic and get a lot of the data up front that that the Swagger definition file may not necessarily have? Well, if you have all of those things together, you can actually use both of those things to create very robust and very dynamic and intelligent services right out of the box, right? By combining the recorded traffic with a definition file, we can automatically create a service that not only contains the intelligent correlations that this virtual service requires in order to complete end-to-end flows, but it also constrains to the structure of the virtual service as defined by the definition files. And not only that, but we can also templatize this flow. So if we templatize this flow, we can then take any newly acquired traffic or any newly recorded traffic, and we can simply push that traffic to our virtual services using the template, because we already know the structure of those API calls. We already know the schemas, and we already know where all of that data is supposed to sit in order to complete this end-to-end flow. So with that, let's actually take a look at a virtual service here. Let me go ahead and share my screen. So we have a simple API here. This is a banking application that allows us to do some common operations. This is basically the underbelly of this bank application. This application does have a front end that we can go to and request loans and do all these operations. But behind the front end, there's a set of API calls. Things like being able to get account information, customer information, database calls, loans, various other miscellaneous operations. And so we may have a requirement to actually to create a virtual service or a virtual representation of this backend system that allows us to do some of these operations in a dynamic way, right? Not just serving up static responses, but serving up stateful responses that can facilitate a complex end-to-end flow. And I do have a virtual service that I actually created here. So we're going to go ahead and access this virtual service. And the virtual service, doesn't necessarily have to have the exact replication of functionality that our real service does, but it has to have enough for us to be able uh, to do some of those operations. And so I just went ahead and loaded up that service, so you can see that um, some of those operations we have virtualized, right? Things like authorization, things like customer account information, stock positions. And then since this is a sandbox that I can personally access and I don't necessarily need to share this data with anyone else, I do have some specific sandbox operations that I can perform inside this virtual service as well. But to test it and make sure that they can actually return data as expected, there's this get customer ID call that we can execute, and we just need a customer ID. If we go ahead and try it out, it looks like we do have some data in our virtual service here for a specific user, right? So there's a customer with user ID 111, first name John, demo, an address, a phone number, and even a social security number. For a stateful virtual service, we want to make sure we can actually update this data, that not only do these post calls work and return the right type of response, but that data also persists. So if we were to actually execute another operation here in this virtual service and perhaps update our customer information for our John demo user, perhaps we can add a different phone number, something like that, for example. And maybe we'll update the social security number here as well. And of course, there's some other required fields that we can fill out here. If I go ahead and run this API call, I do get a response from the server. Looks like the API call did go through, but in order to validate these changes that this information was actually updated, I need to go back to my get account info call. And if we go ahead and run it again, we should see the data for the user changing, right? And this is a great example of that type of stateful behavior. So if I have other services or I have other applications that are calling this the service or creating additional users or updating user data, I know and I'm confident that that data will persist and that data will be able to support complex end-to-end flows. But in order for us to maximize the ROI, we need to make sure that these services are available to everyone, not just me, right? Not just a single user that is able to sort of reset this data. And in that sense, what we're going to do is we're just going to go ahead and leverage our orchestration platform in order to essentially create a new instance of this virtual service, right? So this virtual service here is currently deployed on a specific port. If I go ahead and deploy this service on a different port, I can go ahead and do that. We'll just go ahead and execute this step here. And this really takes us to our next topic here, which is the ability to deploy virtual services and virtual environments dynamically, right? If I created a virtual service that can support complex end-to-end flows, I want to be sure to be able to deploy those complex flows and deploy those environments automatically as a part of either a CI/CD process, or if someone from another team requests access to the service, I can deploy it on demand. And we can do that because we already have all the moving pieces defined, right? So we can reuse the same proxies, we can reuse the same monitors to point our application under test to the virtualized server, to that virtual service. We can develop hybrid models where maybe it starts with a real endpoint, but then fails over to a virtual endpoint, or vice versa, where first it tries the virtual endpoint, but maybe if the data is not there, it will actually go to the real endpoint and grab that data and push it to the real service. It gives us a lot of flexibility, and it allows us to stand up these virtual services on demand, leveraging Jenkins, Azure DevOps, GitHub Actions, any of those automation tools that drive our test pipelines or deployment pipelines. This is called an environment-based approach to testing, right? Defining not only single endpoints, but defining a collection of endpoints that fit the overall system. So by configuring a specific environment instance, a user can actually develop environments that serve a purpose for any type of testing, right? Any type of testing along your test automation pipeline. You may have environments that are specifically dedicated uh, to the code analysis portion, or mocks or stubs in order to facilitate unit tests. You may also develop environment instances to support functional testing, or a specific environment to support performance testing, penetration testing, non-functional testing. All of those types of environments that can be deployed dynamically as a part of your CI/CD pipeline to give you a true quality snapshot of your application under test within a historical context, without those common agile roadblocks attributed to environment instability or environment availability. If we go ahead and go back to our virtual service there that we deployed, it looks like we're able to create a new service. And if I actually go ahead and now try to access another virtual service that we stood up on a different port, I now have a completely isolated sandbox here for any other user to consume, right, with its data in its initial state, which means that if I actually run this get customer ID call again, I should see its initial data set, right? So if we look at it, there's our data, John, Parasoft, right? As you can see, that is different from what we had in the other service that I had. And if I want to go ahead and make changes here and update this data set to update the contact information for my user, I can do that without worrying about other teams having essentially messed up their end-to-end flows because of modifications or changes to their data set. So we're able to isolate those types of those services, and we're able to isolate those types of data sets. Now that we've been able to stand up services for everybody, we need to make sure that we can take advantage of all that hard work we've done, right? If we've developed all of these services, we want to maximize that ROI. We want to maximize the return on investment here, and make sure we're getting all the value from service virtualization. So in order to do that, it's important to be able to monitor your services and monitor the utilization across your platforms. So seeing how other teams are consuming your services, the numbers of hits, the response times associated with those services, allows you to monetize and create some sort of chargeback model in order to gain additional ROI from your investment in service virtualization, and from all the work you've done in order to create these complex end-to-end flows and virtual services. So with that, to wrap up today, to maximize ROI, to unlock that additional 10% of your use cases, you need to go beyond. You need to go beyond simple mocking, simple stubbing, right? You want to create powerful virtual services in order to support your local environments, as well as your stage test environments, dev environments, sandboxes, sales environments, training environments, so on and so forth. You want to make sure you're leveraging things like CRUD operations. You want to make sure you're leveraging things like sequence responders in order to add state and to add logic to your virtual services. To maximize ROI, you want to make sure you're able to monitor and you have an orchestration platform and a governance platform that actually allows you to consume the utilization data and reuse that utilization data in order to create a chargeback model for maximizing the ROI. And of course, it's going to be a big return on investment when you're able to do things like shifting left, enable test automation for complex end-to-end flows, enable the ability for testers to chase those records, to have all the data necessary in order to do complete functional and non-functional testing. So to get started, please visit parasoft.com, where we have our Parasoft Virtualized Community Edition. A lot of the functionality that you saw today, you'd be able to replicate using the Community Edition. There's additional resources there, blogs and white papers that you can reference to see more details about how you can achieve complex end-to-end scenarios with service virtualization. And with that, today we can go ahead and conclude. It looks like we do have some questions here that came in to our talk today. So I'll go ahead and start there. Our organization has adopted service virtualization, but we're struggling with measuring the adoption across the board. How can we do that? That's a great question, right? So again, having an orchestration platform, having not only access to desktop clients and sort of monitoring that licensing and understanding how those licenses are being utilized across the board, but actually being able to monitor the services themselves and being able to assess those deployments and having access to those deployments across the board will help you understand how your organization is adopting service virtualization and for which types of use cases and which types of services. So having access to that type of platform for Parasoft CTP plays exactly that role, where it's a thin client interface that allows you to monitor and understand usage across your organization with regards to virtual services. Does exactly that. Does Parasoft support SFTP? Yes, Parasoft does support SFTP. This is a great question. Can Parasoft update values in a database? Yes. So again, this is where it's important to pick the right service virtualization solution. Your service virtualization solution should be able to work with databases, query databases, connect the database either to pull data or consume data or update data on the fly or on demand based on the requirements, based on your testing requirements or the requirements for your environment. And Parasoft can do that with a vast majority of common databases and data types. So it looks like that's actually it for all of our questions today. Again, thank you for joining today's presentation, and we'll see you next time.